Well, another way to visualize functions of two variables is to examine its level curves, and I will try my best to explain level curves.
Or do not. There is no try.
Oh, well then I will explain the idea of level curves. These can be found by letting z take certain values and graphing z equals f of xy in r squared, not in r cubed. So you should be familiar with contour maps, giving elevation, and weather channel maps may be showing temperature and things like that. They're called isotherms, or pressure, that's called isobars. I suppose I could show you one of those now, but I might get whacked with some copyright issues if I did that. But another use of this is in electricity, where electrical potential fields are represented with equipotential lines. Same kind of idea. So the level curves for the above ellipsoid, that's this one here, or actually that's half an ellipsoid, where z equals 0, 1, 2, or 3, or 4. Don't ask me why. 4 is there too. Actually, there's a reason why. 0, 1, 2, or 3, and then 4 is there too, but it's just a point. Because if you put into our function up here this equal to 4, then x and y would both be 0, so it's just going to be a point. The other level curves, you can actually see them on the graph. Like if z was equal to 1, then this ellipse, where z equals 1, where z equals 2, there's an ellipse here. Where z equals 3, there's an ellipse here. And hopefully you can see how these level curves are generated. Again, I drew the graph, and then bear with me, I also drew the level curves of the graph, if you can see that down there. Unfortunately, I can't stop the z at 0, so I have to draw the bottom half too. But there's a point down here that shows the level curve where z equals 4, and each of these ellipses shows, like this one would be the ellipse where z equals 1, or sorry, 3. This one where z equals 2. This one where z equals 3, when z equals 4. Wait a minute, I got that wrong. This one when z equals 0. This one when z equals 1. This one when z equals 2. I don't know if I have 3 on there. It might be so close to the 2 you can't really tell them apart. Perhaps I could make that visible, but bear with me, I'd have to make this picture a lot bigger. Let me see if I can make that visible. Yeah, you can see there's a little bit of a difference between z equals 0 and z equals 1, which is just like the slight difference between this ellipse and the one at 1, this ellipse right here, right? When they're projected down into the xy plane. Although it is not the xy plane, that's the plane, looks like the plane z equals -4, but normally that would be up here. I just can't control that part. Sorry about that. Still, nice example, I hope. Let's go sketch the level curves for the function in example 1. Okay, so here's another example. I almost lost that one, sorry. Got stuck behind other stuff. Okay, here we go. The level curves for the function in example 1. That's this function, remember? Well, let's do it. And here it is. Now, I know I have a little different coloration on it this time, but you know, if you let z equal 1, then we got 1 equals x squared plus y squared over 4, and then the level curve would be the circle. 4 equals x squared plus y squared, so it would be the circle, radius 2, center at the origin. So for z equals, what did I say it was, 1 down here, our level curve would be this blue circle. And if I were to say, yeah, well, what about z equals 2? Well, then 2 equals x squared plus y squared, so 8 equals x squared plus y squared. Oh, sorry, that was x squared plus y squared over 4, so 8 equals x squared plus y squared, circle center of the origin, radius 2 square root of 2, square root of 8 if you want, and that would be the next circle there. So we could go on doing that if we wanted, and we would get that. By the way, I didn't try this one. When z equals 0, which is certainly a possibility, then you just have the level curve would be just the point here. Wow, I never noticed it would do that, but it would flip. Wow, that's really cool. I guess it doesn't matter what plane you draw the level curves in. It certainly doesn't matter this software. There, this way I kind of like it better. This one would be the level curve z equals 1. This one maybe z equals 2, 3, and 4, etc. And it's really cool. So let's see one more of those. Sketch a contour map of the above by hand. Oh, painful, painful. So if z equals 1, when we got this circle, z equals 2, we got this circle, z equals 3, we have this circle. So we got concentric circles whose center is at the origin and whose radius varies from 2, square root of 8, square root of 12, maybe 4. And here's the sketch. Well, this is me drawing it with paint. So when if z equals 0, then we just have this point. If z equals 2, then we got 1, and x squared plus y squared equals 4. Anyway, I think you could see that. But I did it, so to speak, by hand, although I didn't really use it by hand. I used Microsoft Paint, if that's acceptable. So, well, another video for the next problem.